Hello, I will talk about spatial relativity and the twin paradox. Spatial relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of spatial relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system. And the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V. So the distance between Earth and the star Epsilon is 10 light years. And the brother that is on the spaceship actually does the distance back and forth. So it is 10 light years in each side. It is 10 light years in each side. So the total distance back and forth is 20 light years, and the speed of the spacecraft is 80% of the speed of light, that is 240,000 kilometers per second. So the total way divided by the speed is the total time that will take to the brother to do the journey. So it is actually 25 years. So that is the time that will pass on Earth. And according to the Lorentz transformation, the time measured by the twin in the spacecraft is t spacecraft equals to t naught times root of 1 minus v squared divided by c squared. So the time that is measured in the spacecraft will be the time that was measured on Earth. Total time is 25 years, times the root of 1 minus v squared divided by c squared. So because of the fact that the twin brother that is in the spaceship travels at very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation or time lengthening. So the brother on Earth sees his brother traveling on the spaceship at very high speed. So from the point of view of the brother that is on Earth, there will be a time dilation on the spaceship. His twin brother on the spaceship, there the flow of time is the rate of time flow in the spaceship is slower than the time flow on Earth. So that is the reason that the total time that is passed on the spaceship is only 15 years, 10 years less than the total time that passed on Earth. That is 25 years. And this phenomenon is called time dilation or time lengthening. The rate of time flow in the spaceship is slower than the time flow on Earth. This is because the brother in the spaceship is traveling at very high speed. So the time in the spaceship slows. The rate of the time flow in the spaceship is slower than the time flow on Earth. Okay. So the total time that will pass on the spaceship is 15 years. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at the speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation, so the distance it must travel is L spacecraft equals to L naught times root of 1 minus v squared divided by c squared. So the distance between Earth and the star Epsilon actually shrinks from 10 light years to 6 light years because when someone or something travels at very high speed towards you, there will be a contraction of distance between you and the object that travels at very high speed, according to special relativity. So because of the fact that from the point of view of the brother that is on the spaceship, he is at rest and the star epsilon is moving towards him at very high speed. So according to special relativity, in this case there will be a contraction of distance between the brother that is on the spaceship and the star epsilon. So the original distance was 10 light years, and because that star Eridanus is moving towards the brother that is on the spaceship, because it is moving in very high speed towards the brother that is on the spaceship, there will be a contraction of distance. And the distance will be no more 10 light years, but the distance will be shrinked to only 6 light years. And that is according to the theory of special relativity, contraction of distance. Okay? So now we must calculate what will be the total time that will pass in the spaceship after we know that the distance contracted to 6 light years only. The distance between Earth or the brother that is on the spaceship and the star Eridanus contracted to 6 light years only. So the total time that will pass on the spaceship will be T spaceship equals to 2 times L spaceship divided by V. So it is actually 2 times 6 divided by 0.8, and the total time that will pass in the spaceship will be 15 years only. So because of contraction of distance, the total journey back and forth from the spacecraft to star epsilon and back from the star epsilon to Earth will be only 2 times 6 light years, because it is back and forth. So the total distance is 12 light years, and the speed of the spacecraft is 80% of the speed of light. So the total way divided by speed is the total time that will be passed on the spaceship in all January. Okay, then the total time is 15 years. It is 10 years less than the time that is passed on Earth. Okay? So, therefore, the two twins effectively agree that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to the effect of time lengthening or time dilation, as I have already explained. That from the point of view of the brother that is on the space, he is at rest and his brother is moving at very high speed. And that is the reason that in the spaceship there will be time dilation. So the rate of time flow in the spaceship will be slower than the time flow on Earth, and that is the reason that the total time that will be passed on the spaceship will be only 15 years. And according to in terms of his traveling twin, uh, it will be 15 years due to the contraction of distance. As I have already explained, the distance between the spaceship to star Epsilon contracted to only 6 light years. So back and forth is 12 light years. Total way is 12 light years, and the speed is 80% of the speed of light. So when we divide the total way in the speed, 12 divided by 0.8, it will be 15 years only. Okay, thank you very much.